Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss some important questions of linear combination of variables. Question number 9. A journey in a certain car consists of two stages, with a stop for filling up with fuel after the first stage. So there are two stages and a stop for filling up with fuel after the first stage. Here is the rough sketch of this situation. Two stages means T plus T and a stop for filling up with fuel after the first stage. The length of time T minutes taken for each stage has a normal distribution with mean 74 and standard deviation 7.3. So T follows normal with mean 74 and variance 7.3 square. The length of time F minutes it takes to fill up with fuel has normal distribution with mean 5 and standard deviation 1.7. So this F follows normal with mean 5 and variance is 1.7 square. The length of time it takes to pay for the fuel is exactly 4 minutes. So 4 minutes to pay, and this is fixed. The variables T and F are independent and the times for the two stages are independent of each other. Part 1. Find the probability that the total time, total means sum, for the journey is less than 154 minutes. So total time means T plus F plus 4 plus T. See, T plus F plus 4 plus T. This sum will give you total time for this car. So it should be 2T plus F plus 4. This is car 1's journey, the journey of car 1. And we need this probability. Probability 2T plus F plus 4 less than 154. This is the requirement of this part. The total time for the journey is less than 154 minutes. So C1 is T plus F plus 4. Therefore, the mean of C1 is E bracket 2T plus F plus 4. So this 2 is here, ET is here, EF is here, and 4 is here. So this is the mean of car 1, 157. Now variance of car 1. Don't square this 2 because this 2 is not multiple of this T. Just copy those 2 as it is. So 2 times Vt, Vf, and variance of constant is always 0. So this is the variance of total time of car 1's journey. Since we need this probability, so convert this statement into Z 154 minus mu over under root sigma square. You can simplify this yourself and complete this part yourself. The second part of this question. A second car has a fuel tank with exactly twice the capacity of the first car, meaning F2 is 2 times F1. Find the mean and variance of this car's fuel fill up time. This is very simple. We just need to find mean and variance of this. So in mean, copy this 2 here and EF1 is here. So this is the mean of EF2. And in variance must square this number, this coefficient, because this 2 is multiple of F1. So when number is multiple, then always square the number while working for variance. So here is the variance of F2. So this is the answer of Part 2. Part 3. This second car's time for each stage of the journey follows a normal distribution with mean 69 and standard deviation 5.2. This is T2. It's 69 and 5.2 square. Time for each stage. The length of time it takes to pay for the fuel is exactly 4 minutes. Find the probability that the total time for the journey taken by the first car is more than the total time taken by the second car. So we need this probability, C1 greater than C2. And this same sketch will be used for the journey of second car. So according to that sketch or this sketch, the total time of the journey of second car should be T2 plus F2 plus 4. So it should be 2T2 plus 4 plus F2. Now we need to find the mean and variance of this equation. This is the mean of the total time of the journey of second car. T2 and 4. In variance, don't square this number because this number is not multiple of T2. So this is sigma 2 square. Since we need this probability, so first find mean and variance of this C1 minus C2. C1 minus C2 means mu1 minus mu2. This is 5. In variance, we always replace negative sign by positive sign because variance is always positive. So this is the variance of C1 minus C2. Now convert this statement into Z. 0 minus mu over under root sigma square. And here is the final answer. This question is very important. You can find the link of the math website in the description where you can find the soft copy of this lecture. Question number 10. I told you whenever equation is given, then coefficients of the variables are always multiples. Question number 10. A mathematics module is assessed by an examination and by coursework. So there are two things, examination and coursework. The examination marks up 75% of the total assessment, 0.75x. And the coursework makes up 25%. That is why we have 0.25 here. Examination marks X are distributed with mean this and standard deviation this. Coursework marks Y are distributed with mean this and standard deviation this. Examination marks and coursework marks are independent. Find the mean and standard deviation of the combined mark. We need mean and variance of this. This is very simple. In mean, we copy the coefficients. This is EX and this is EY. So this is the mean of this equation. But in variance, must square these coefficients, 0.75 square, and multiply 0.75 square with the variance of X, which is 9.3 square. 0.25 square times 5.1 square. This is the variance of this equation. You can check this solution again. In variance, you have to square the coefficients of the variables. These two things are very important. Next question. 11. A certain make of washing machine has a wash time with mean 56.9, standard deviation 4.8. So this is the wash time. A certain make of tumble dryer has a drying time with mean 61.1 and standard deviation 6.3. So variance is 6.3 squares. Both times are normally distributed and are independent. Find the probability that a randomly chosen wash time differs. Differs means modulus. So the word differs means modulus. More than 3 means this thing. So we need this probability. This is the requirement of this question. You all know how to remove modulus, how to simplify this equation. So whenever we have greater sign, we write d minus w, this thing, less than minus 3. And d minus w greater than 3. So first work for the mean of d minus w. So mean of d minus w is ed minus ew. So this is the mean of d minus w. In variance, we replace negative sign by positive sign. So this is the variance of e minus w or d minus w. You can write this as d minus w. In variance, it doesn't matter whether you write w minus d or d minus w. They both mean the same thing because of this positive sign. Now, first find this probability and then find this probability and then add both the answers. So d minus w less than minus 3. First convert this statement into z. Minus 3 minus mu over under root sigma square. So this probability's answer is 0.1817. This is a small area, so it should be 1 minus 5. Now find this probability and then add both the answers. D minus W greater than 3. This is a large area, so it should be 5. Now add these two answers. This is the final answer. Next question, number 12. Climbing ropes produced by a manufacturer have breaking strengths which are normally distributed with mean 160 and standard deviation 11.3. This is the mean and this is the variance. A group of climbers have weights which are normally distributed with mean this and standard deviation 7.1. Part 1. Find the probability that a rope chosen randomly will break under the combined weight of two climbers. So basically this probability is required. Two climbers means C plus C greater than R, the strength of the rope. Or you can write this as 2C minus or 2C greater than R, and then you can write this as 2C minus R greater than 0. So this probability is required. This is here. This is the requirement. Now first find mean and variance of this equation. This 2 is not multiple of this C. So in variance, don't square this 2. Copy this 2 as it is. So in mean, write this 2 here and multiply 2 with the mean of C, which is 66.3, and then minus R. So this is mu and this is sigma square. 2, copy 2 as it is and then multiply this 2 with the variance of C, and then minus R means plus R, 11.3 square, because variance is always positive. Now for this probability, convert this statement into Z. So 0 minus mu, since mu is negative, so we have positive sign here. And this is under root sigma square. Here is the final answer. This is a small area, so 1 minus 5. And make sure you give your answer up to 3 significant figures. The second part of this question. Each climber carries in a rucksack equipment amounting to half his own weight. Half means multiple. So this means C plus 0.5 C. Half means 0.5, so it should be 1.5 C. So this 1.5 is multiple of this C. Find the mean and variance of this 1.5 C. So mean 1.5 into mean of C, and in variance must square 1.5 because this 1.5 is multiple of this C. So this is the variance and this is the mean. Part 3. Find the probability that the combined weight of a climber and his rucksack is greater than 87. So we need this probability. 1.5 C is greater than 87. This is very simple. We have mean of 1.5, mean and variance of 1.5 C. So we just need to convert this statement into Z. 87 minus mean of this and upon sigma square of this. This means large area, so it should be 5. And this is the final answer up to 3 significant figures. 13. Next question. The random variable x has the distribution. This sum means total, of 60 independent observations like x plus x plus x. So 60x. We need this probability. Since this 60 is not multiple of x, so we will not square this 60 while working of the variance of s. We will copy this as it is, like this. So this is the mean of this 60 ES, and you can write this as E60x. So 60 is here and EX is here. So this is the mean of this 60x or S. In variance, just copy the 60 as it is. Here is the variance of this S. Now we need this probability. This is very simple. You can complete this solution yourself. Next question. Number 14. The cost of electricity for a month in a certain town under scheme A consists of a fixed charge of 600 cents together with a charge of 5.52 cents per unit of electricity used. So the equation of the cost, total cost, is 600 fixed charge and then 5.52 per unit. If units are x, so 5.52 times x. Stella uses scheme A. So this is the equation for scheme A. The number of units he uses in a month is normally distributed with mean and variance is this. So this is the equation for scheme A, and we can easily find its mean and variance. Make sure you must square 5.52 while working for the variance of this equation. So here is the mean, 600, 5.52, mean of x. In variance, variance of constant is always 0, and 5.52, this must be square because this is the multiple of this x. Here is the variance of this equation. And we have done this first part. We had to find mean and variance of C. Part 2. Under scheme B, there is no fixed charge and the cost in cents for a month is normally distributed with mean this and variance is this. Derek uses scheme B. So scheme B. Find the probability that in a randomly chosen month, Derek spends more than twice as much as Stella spends. So D greater than 2S. This is the requirement. or you can say y greater than 2x. So this is scheme B, and we need this probability. We can write this as x or y, or just d or s. It's your choice. So d greater than 2s. So bring this on left hand side of this inequality. So we need this probability. So d minus 2s, this is the mean of d, and this negative 2 is here, and this the mean of s is here. Invariance, convert this negative into positive, and must square this 2, because this 2 is multiple of this s. Now convert this statement into z. 0 minus this, so because of this minus, this will be plus. And I think this is a small area, so it should be 1 minus 5. And here's the final answer. I hope this lecture will help you to understand how to solve linear combination of variables questions easily. An important advice, keep smiling, as it's sunnah of Holy Prophet Muhammad sallallahu alaihi wasallam. Good luck to everyone. Allah Hafiz.